The session is being recorded. Participants who accidentally leave can rejoin the webinar using the same link. The presentation slides will be shared with all participants after the webinar. Okay, 1 second. Welcome to those who are joining us. So our speaker today is me, Engineer Matthew Mwenga. I'm the Managing Director of Ren Engineering Solutions. I'm a registered professional engineer in Kenya, in the UK, and I have 14 years of experience in compressor and petroleum industries. So who are we? Ren Engineering. Ren Engineering Solutions is a company that provides best-in-class compressed air solutions to improve both productivity and reliability of manufacturing industries. We help you do this by focusing on a total systems approach. That means from the compressor room to the user point. And we also use a data-driven approach that starts with the baseline. Think of the baseline as an audit. For energy, we do energy audits, and for quality, we do quality audits. After auditing, where we are able to get data on how your system is doing, we analyze this data to determine areas where you can improve. In the third step, we turn our recommendations into reality through design and implementation. And lastly, we verify and sustain any savings or improvements that you make in your system through methods of verification and sustaining, such as compressed air energy monitoring and other systems related to that. So getting to our agenda for today, I'll start with a short introduction about the topic of compressed air quality. I will then look at the different GFSI schemes, and I'll explain what that is and the guidance. We'll then look at how to meet the standards, these standards using Hasp principles. We'll then look at some of the compressed air quality standards out there, how to sample your compressed air quality, and our testing solutions. We'll then have a Q&A session where we'll get to take your questions regarding this topic. So why do we need to test compressed air? Safety is one of the most important tasks in the food and pharmaceutical industries today. Manufacturers are under increasing pressure to meet the required quality standards. They also take great care to ensure quality throughout the entire value chain, that is from transportation and packaging. An important influencing variable in safe food and pharmaceutical production that is never given the necessary attention and is usually ignored is compressed air. And that's our focus for today. So why exactly do we need compressed air? Well, compressed air applications in industries are divided into three main categories. The first is power applications. Power applications include areas where air is used either to produce a motion or exert a force. such as linear actuators, jackhammers, like the picture that you see there, clamping devices, or even blow molding, a process that is commonly used in plastics manufacture. The second set of applications that interests us today is process applications. This is where compressed air is used in the process itself. So compressed air can be an ingredient or actually coming into contact with your products. Some examples of this include combustion, liquefaction, hydrogenation of oils. Compressed air is also extensively used in brewing and the manufacture of ice cream as an ingredient. The last set of applications is control applications. These include applications where compressed air is used to start, stop, trigger, or modulate processes that need to be automated. This is commonly known as instrument air and very common in most of our factories. So compressed air applications, as they relate to food and pharmaceutical, include things such as using compressed air for mixing ingredients, cutting, spudging, drying products, transportation of things like powders, cleaning containers before product filling, automated product sorting, which is used in industries such as macadamia nuts and even coffee to sort out some of the grains that are damaged or not fit for consumption, and final product packaging systems. So what are some of the types of compressed air contact with food and pharmaceutical products? The first is indirect contact. For example, ice cream and yogurt jar cleaning. So the compressed air comes into contact with the product packaging during either drying or cleaning of the packaging. The second type of contact is direct contact, where the compressed air is an ingredient or is mixed with a product for transportation or other activities like that. And the last type of contact is no contact at all. A good example is instrument air for automating processes, which doesn't come directly into contact with your products. In this next section, we'll focus on GFSI scheme requirements and guidance. So what is GFSI? GFSI stands for the Global Food Safety Initiative. It's a business-driven initiative for the development of food safety management systems. You can think of GFSI as an umbrella body that certifies different food safety schemes that meet its standards. Today, we will look at some of the requirements for compressed air that fall under different food safety schemes that are recognized by GFSI. The picture on the bottom right shows different food safety schemes that are recognized under the Global Food Safety Initiative. So we'll start with the BRC Food Safety Scheme, the British Retail Consortium. In this food safety scheme, air under direct contact should be monitored. Looking at the FDA on the right of your screen, in different sections of their standards, they have stated that air shall not pose a risk of contamination. In another section, compressed air or other gases mechanically introduced into food or used to clean food contact surfaces or equipment shall be treated in such a way that food is not contaminated with unlawful or indirect food additives. Note that we try to summarize what these subsections say, and so we might not have listed it word for word. The next set of food safety schemes that mention compressed air is IFS, the International Featured Standards. In two different sections, it states that air in direct contact shall be monitored, and also compressed air shall not pose a risk of contamination. Looking at the Primus GFS food safety scheme, air in direct contact shall be monitored regularly. The next food safety scheme that is very recognizable and used a lot here locally is FSCC 22000, which is a combination of ISO 22000 and the BSI PAS 220. So in ISO 22000, it is stated that prerequisite programs should be in place to address supplies of air. In the BSI PAS 220, it is stated that compressed air systems shall be constructed and maintained so as to prevent contamination. Requirements for filtration, microbiology, and humidity shall be specified. Filtration of the air should be as close to the point of use as is practicable. The last food safety schemes that we'll talk about today is the SQF. In different parts of this standard, it states that air and gas in contact shall be monitored. Systems must be maintained and monitored. In addition, air filtration at the point of use should be at least 0.01 micron. The common thread in all these food safety schemes that all fall under GFSI is that you need to pay attention to the quality of the compressed air you use in manufacturing your products. So we come to the first question of the day. Does your industry regulate compressed air quality in this country? I would like to request that you give your answers on the chat box, and we can see that if you're aware of any regulation of compressed air quality in your industries. Kindly give your comments on the chat box. Okay, thanks. I'm seeing quite a few yeses coming through. Yes, food safety standards that you use locally, and especially because in Kenya we have ratified some of these standards under KEBS, such as FSCC 22000, the quality of your compressed air is regulated and you should definitely monitor it. In the next part of this presentation, we will look at how to interpret quality requirements through the lens of HACCP principles. And I'll just quickly explain what is HACCP, HACCP. HACCP stands for Hazard Analysis critical control points, which is an internationally recognized method of identifying and managing food safety. So we'll look at how you can use the 7 principles of Hasp to ensure that your compressed air meets the required quality standards. So this slide gives a summary, but we will go through each principle one by one. So principle 1 of hazards Hasp is identify hazards that must be controlled to acceptable levels. The key word here is hazard. So what is a hazard? In relation to food and pharmaceutical, a hazard is a biological, chemical, or physical agent that is reasonably likely to cause illness or injury in the absence of its control. Untreated compressed air contains several contaminants that must be removed or at the very least reduced to acceptable levels. The key contaminants for compressed air are particles, which is available in the air that we are breathing, water, oil, and microorganisms. These are the 4 principal hazards in compressed air. Some of them are available in the air that we are breathing, and some of them can be introduced into the compressed air by either your compressor or your compressed air system. The key thing to note is that you would definitely not use the same quality of compressed air for sandblasting, for example, or jackhammering as you would use for your food and pharmaceutical industry. The second principle is identify critical control points. A critical control point is a step at which control can be applied and is essential to prevent or eliminate food safety hazard or to reduce it to an acceptable level. One of the key critical control points in a compressed air system is the compressor itself. So if your compressor is oil lubricated, one way of reducing the risk of contamination is to use food-grade oil. Another option is to use an oil-free compressor. To eliminate the risk posed by particles, you can use different levels of filtration, including coalescing and adsorption filters. And most importantly, at the point of use, where air comes into contact with the product, you can include filtration to ensure that the air is of the right quality. Principle 3 of Hasp states that you need to establish critical limits for the critical control point. Now, what I've found is that many multinational industries have already defined the quality of compressed air that should come into contact with their products, but many other industries have not. So a critical limit is the maximum or minimum value to which a biological, chemical, or physical parameter must be controlled at a critical control point to prevent, eliminate, or reduce to an acceptable level the occurrence of a food safety hazard. What that means, and we'll go through this a bit later, those 4 contaminants, particles, water, oil, and microorganisms, it is important that you establish the maximum amount of contamination that is allowable. Some of the recommendations out there are For example, SQF recommends that compressed air in contact with food shall be filtered and treated, and the filter should be changed at a predetermined frequency. SQF also recommends a 0.01 micron filter at the point of use. Your point of use filters are your last defense against contamination being introduced in your product. And we look at why. Now, this slide explains why a 0.01 micron filter is frequently recommended. If we look at the size of bacteria, this is frequently between 0.2 and 10 micrometers. Molds can be between 10 and 30 microns, and yeast between 3 and 40 microns. So your 0.01 micron filter will ensure that not only does it eliminate large particles, but also any colony forming units or CFUs from getting into contact with your product. It's important that you get a filter that has a high efficiency such as 99.999% at the point of use. The fourth principle is you need to implement monitoring at the critical control point. To monitor is to conduct a planned sequence of observations or measurements to assess whether the critical control point is under control. And of course, have a record for future reference. And this is especially true during audit period when auditors will want to see a record that you have tested your compressed air. So the monitoring plans can take different approaches. One is a percentage based, where you say, we will test 25%, 33%, or even 50% of the critical control points where air comes into direct contact with our products. Another approach is maintenance based, where you could do a quality test before and after filter changes. This could help you determine how frequently should you change the filters. Another one is to use a minimal based approach, where you take 3 or 4 measurements as close to the point of use as possible. And lastly, you could also take a single test annually. This will give an idea of where you are and is a very good first step in determining the quality of your air that is coming into contact with your products. Moving to principle 5 of Hasp, you need to establish corrective actions when not in control. Corrective means procedures followed when a deviation occurs. So what happens when you do the test and you find that you have more particles than you expected or a lot more oil than you expected? That means probably that the filters that you rely on to protect your point of use might not be working. But it is very, very important to find out what is the correct cause of non-compliance. So it's very key to find the root cause of the non-compliance. So if there is water, is it an issue with the dryer, or is it water that is introduced into the system due to leaks within your compressed air piping? So that is key to find out what is the root cause, so that when you prescribe corrective actions, they are done at the right place, and then you record these corrective actions, right? For example, if you have more particles than you expect, The solution could be introducing the right filter. If there is a deviation in terms of water, then maybe you need to either repair or introduce a dryer. The next principle that we will talk about today is establishing verification procedures. These are activities other than monitoring that determine the validity of the Hasp plan and that the system is operating according to plan. So it's recommended that you review the original hazard control critical point plan. It's also recommended that you review this plan every time there are major changes to the compressor or the piping. Every time there is a change in the filter brand or model. You should also review your plan when corrective actions are taken. So it's very, very critical that verification is done to ensure that the Hasp system is functioning according to the plan. And lastly, establish record-keeping procedures. Record-keeping is the process of creating and maintaining records. So what are some of the records that you would need to keep in relation to your compressed air system? These include hazard analysis results, critical limits that you have set for the contaminants, particles, water, oil, and microorganisms, compressed air testing results, corrective actions that you have taken, any training records for the team that handles quality, and even the sampling procedures that you use, and even the schedule that you have prescribed for your plant to ensure that it meets the quality standards. I will encourage you to write out your questions in the chat box as we go along, and we'll be able to handle this during the Q&A session that is coming up. So what are some of the compressed air quality standards out there? So we have two sets of standards which differ quite significantly. For manufacturing air, we've just discussed that the critical contaminants are particles, water, which can be in the form of vapor, aerosols, or liquid, oil, which could be in the form of vapor, aerosols, which are small droplets or liquid, and microorganisms. Manufacturing specifications are designed for manufacturers and their products. While for breathing air, testing is more concerned with any contaminants that could pose a danger to human life. These include gases such as carbon monoxide, carbon dioxide, nitrogen, and other contaminants such as water, condensed hydrocarbons, and other contaminants. It's important to note that breathing air tests and manufacturing air tests are very different. ISO 8573 is the most critical standard when considering compressed air quality. This standard defines compressed air quality classes and is the common language that links you, the manufacturer, who would like a specific quality of compressed air, and the manufacturers of equipment. By specifying your quality class, using this standard, any manufacturer will be able to give you a solution that meets the quality standards. So I'll just explain a little bit what this chart means. And the table shows a variety of purity classes. On the left, you will see purity class 0, 1, 2, 3, 4, 5 increasing. So 0 is the most stringent purity class, while 9 is the least. Then, as you go on the right, the three main contaminants, particles, water, and oil, are listed on the first row. So what you find against each purity class is what are the limits in terms of contamination for your air to meet each purity class. For example, if your air meets class 1 for particles, then the limit in terms of the allowable number of particles of different sizes are defined along that row. You will also find for water, class 1 is less than or equal to -70 degrees Fahrenheit pressure dew point, while for oil, class 1 means less than or equal to 0.01 micron. Another key thing to note is that oil-free compressors will only ensure that you meet the purity class 0 for oil. In order to remove contaminants such as water, you do need a dryer, and for particles, you will need the right filter. This slide explains just a bit more about purity classes. So let's say, for example, as a manufacturer, you specify, such as example 1, you specify that the purity class that you want for your plant is ISO 8573 class 221. What does that mean? It means class 2 for particles, class 2 for water, and class 1 for oil. So going back to our table, class 2 for particles is defined by less than or equal to 400,000 particles between 0.1 and 0.5 micron, less than 6,000 particles between 0.5 and 1 micron, and less than 100 particles between 1 and 50 micron. Class 2 for water means negative 40 degrees Celsius pressure dew point, which can be provided by a desiccant dryer. And class 1 for oil means less than or equal to 0.01 milligram per meter cubed of oil. So by defining your specified air as class 1, as ISO 8573 class 221, you are able to clearly specify the quality of air you need, and any manufacturer seeing this specification will be able to give you an engineering solution that will ensure that you meet this class in your plant. So what do we recommend? We recommend that for high-risk applications, these are applications where compressed air is an ingredient or comes directly into contact with your product, then the quality class for particles should be between class 1 to 2, for water between class 1 to 3, and for oil between class 0 and 2. It's important to note that class 0 does not mean zero oil What it means is that, just going back a few slides, is that the amount of oil in the compressed air is better than class 1. And class 1, as you can see, is defined as less than or equal to 0.01 milligram per meter cubed. For medium or low risk applications, there is a recommendation given, and also for low risk applications. So what are some of the guidelines out there? The British Compressed Air Association gives guidelines such as 221 for direct contact and 242 for indirect contact. However, as I said, many companies have their own internal standards that are a lot more stringent than this, based on their own risk assessments of what the contamination from compressed air could do to their products. This is an example of the quality air standard for instrument air. As we said, instrument air never comes into contact with your products. So the standard for particles is particles of 40 microns are okay. A maximum of 40 micron is okay. While for water, 3 or 4 degrees Celsius pressure dew point is okay. And for oil, it's less than 1 part per million, or 1 milligram per meter cubed. So with that, you know that the quality of air needed for your instruments is not as critical as that would be coming into contact directly with your products. What is the guidance for the pharmaceutical industry? Here we have the ISPE Good Practice Guide, and they don't specify a specific limit for particles, but for water, they are very clear that the minimum quality should be negative 40 degrees Celsius pressure dew point, while for oil, it should be less than or equal to 0.5 milligram per meter cubed. Again, these standards are just guidance, and it is critical for you as a manufacturer to have your own internal standards based on your own risk assessment. We recommend that for pharmaceutical and food where there is direct contact, then the best would be to go for class 0 oil, at the very least class 2 for water, which is negative 40 degrees Celsius, and class 1 for particles. Another key thing that we may have not dwelled so much on is, what are the microbiological requirements? Have you set a standard internally for the number of CFUs that is allowable in your compressed air? This is something that we find that varies from industry to industry. So we'll just close with a couple more sections. So how do we sample? We take our samples for particles, water, and oil using the filters that you see. So for particles, we use the filter element that you can see. For water, we use a Draeger tube. And for oil, we use the same filter that is used for particles to capture any oil aerosols, while oil vapor, we use a charcoal filter. With this, we are able to take a sample of your compressed air and give you a report that details what purity class your compressed air meets. Sampling for microorganisms is a lot more tricky, and the best-in-class microbial sampler is what you can see there, that is offered by our partner, Trace Analytics. This sampler allows you not only to determine what colony-forming units are in your compressed air, but also what is the number of colony-forming units per unit of compressed air. A lot of the test methods available out there will only tell you what microbials are in your compressed air, but not how many they are per unit of compressed air. So looking at our testing solutions, the most common and the one that we recommend for food and pharmaceutical is the baseline or pro package. Here we test for the 3 key contaminants: particles, water, and oil. For particles, we measure class 1 and 2, water class 1 to 6, and oil class 1 and 2. The next type of test that we perform is the value package that looks at class 3 to 5 for particles, 1 to 6 for water, and 3 to 4 for oil. And this is for non-critical applications where your compressed air is not coming into direct contact with your product. We can also offer microbial sampling in partnership with our testing lab, depending on your requirements. In summary, there are many food safety schemes out there, and a lot of them will require compressed air monitoring and testing. It is critical to apply the principles of Hasp to your compressed air system so that you can manage the risks posed by compressed air to your products. We've also looked at some of the air quality standards and regulations that guide the quality of compressed air. We've also looked at how you can sample your compressed air and how we can partner with you to ensure that the quality of compressed air that comes into your products is of the right quality. So that marks the end of the presentation section, and we now have a Q&A session, and I'm looking forward to answer any questions that you might have regarding our presentation. So you can write your questions on the chat box, or you can put questions on the chat box or unmute yourself and ask a question. So the first question that is here is, if I don't repair or upgrade any of my compressed air equipment, how often should I establish verification procedures? So as I mentioned during the presentation, at least a single test a year will help you determine if all the engineering controls that you have put in, such as having an oil-free compressors, having filters at the point of use and in the compressor room, are working. I've also noted that there was a challenge with the sound. I hope it's been resolved. But again, over to you, our guests. If you do have any questions, I'm looking forward to answer them. So some of the more frequent questions that we get asked are, what's the process of testing like? So what usually happens is if you do need to test for your compressed air quality, we do provide testing where we come in with test equipment and we are able to sample your compressed air and then send the test kits to our partner, and then you get an ISO certified report on the current quality of your compressed air. Any other questions? Or comments around the presentation? Okay, we have a question from Mohammed. So how do I establish the frequency? The frequency is usually determined internally, and it can be based on your risk assessment. So one of the things we do is, of course, as you're carrying your normal risk assessment for food safety or pharmaceutical safety, we have a risk assessment form that you can use. And based on the level of risk, which will be determined by the engineering controls that you've put in, you'll be able to determine whether you should test monthly, quarterly, or annually the quality of your compressed air. So I would say the first step is to do a risk assessment that is focused on your compressed air, and from that you can determine, based on the level of risk, what testing frequency would be suitable for you. I also see a question from Joseph. Yes, we do charge for the testing, and I'd be happy to send you a proposal for quality testing, but we charge for the testing, and what we mainly charge for is the cost of the test kits and also the cost of getting the samples tested by the lab that we partner with. Okay, so we also have a question from Patrick, who is asking, do we do air sampling after the air filters or direct from the user point? So as you do your risk assessment, it's important to determine what are the critical control points, right? So you can decide to test after the air filter, for example, in the compressor room, to determine if that filter is doing its job of reducing the risks posed by particles or oil. But also, and what I see a lot of manufacturers doing is you test at the use point after the filter, after the point of use filter, to actually test the air that is going directly into your product. So to facilitate this, we use specialized stainless steel fittings, which by their nature cannot introduce any contamination at the test point, and we are able to test the air that is actually going into your process or coming into contact with your product. I hope I've answered your question. Yes, so for the pharmaceutical industry, I think I had mentioned that there is the ISPE practice guide that talks about water should be maximum of -40 degrees Celsius. That means pressure dew point. That means you need a desiccant dryer to meet this level of dryness. The next thing is that for hydrocarbons, it should be less than or equal to 0.5 milligram per meter cubed. But we do frequently recommend that for pharmaceutical, oil should be class 0. That means it should be less than what is specified for class 1 in ISO 8573. So just going back to the ISO 8573, you can see class 0 is limits that are lower than class 1, and class 1, the limit for oil is less than or equal to 0.01 milligram per meter cubed. For particles, I would say you would be looking at completely eliminating the colony forming units, and that means that the recommendation for 0.01 micron, so that would be class 0 for particles. Right? So sterile applications, for example. Thank you, Sadiq. Any more questions? We did start 5 minutes late, so we'll probably go a few minutes after the hour. We also have a polling question that should be appearing on your screens. So please take the time to answer this. Yeah, I'm still taking any questions. Yes, Mohammed. So what is the duration of sampling? So normally sample will take between 4 to 5 hours, and the sampling rate ensures that a certain volume of compressed air is sampled, so that is what will be used to determine what is the quantity of contaminants in your compressed air per unit. So for example, the sample that takes the longest is the particles test. So what we usually do is we connect the testing equipment, and then we are able to run the particles and oil aerosols test parallel to taking the samples for water and for oil vapor. But the common duration that I see at site for the actual taking of samples is between 3 to 4 hours. But there will also be some time to modify the test point using our stainless steel fittings, which will allow you to continue production, because what we want is for us to sample as you continue production. So we modify the sample point so that it allows you to continue production even as we are taking the sample. So we have another question from Patrick regarding the performance of filters between 0.2 and 0.1. A lot of this performance is more an issue from the manufacturers of these filters, but I think the guidance that is there from SQF states that you should get a filter that offers at least 99.999 efficiency. So what that is a 0.01, not just 0.1, but 0.01 micron filter at the point of use. And so that's for specifically the sterile applications. Mohammed, I see your question about which guideline allows this duration. So the sampling time is determined by the quality class to which you want to test. For example, if you want to test for class 1 for particles and class 1 for oil, then the amount of time you need to take the sample will be longer. And again, these are things we can discuss with you during the actual test or when we do send you a proposal for quality testing. If you want to take a sample for class 3 to 5, then the duration will be shorter. So the duration of testing is determined by the volume of air that needs to run through the sampling equipment for you to be able to test for a certain quality of air. We still have a couple of minutes for any more questions that you might have, but we are very happy to discuss your quality testing needs and guidance on the duration and any other questions that you might have for your quality tests. So one of the things we'd like to mention is that we have carried out several quality tests here in country for different manufacturers. We've carried out tests for compressed air. We've also tested nitrogen using the same equipment, just to ensure that at the point of use, the main contaminants, that is particles, water, and oil, are in control. And we're able to give not only the test report from the lab that specifies what the levels of contaminants are, but also give recommendations on what is the root cause of this contamination and recommendations on how to get back to within the critical limits that you have set for yourself. Patrick, I see your question about clean room air standards. I believe they are, especially for pharmaceuticals. It's important to cross-check these standards if they specify anything for compressed air. I have to be honest that I've not reviewed this standard with regard specifically to compressed air and what they say about those contaminants, but I know that they are quite stringent with regard to the level of contaminants that are allowable. Okay, Patrick, but what I will do is that I'll take note of this and respond to you on email about clean room standards and compressed air and how they relate. I'll send you an email about this. And then we have one last question from Mohammed. What are the basic precautions during qualification of compressed air at pharmaceutical companies? So the key thing is once you've done your risk assessment and you specify to the manufacturers about the quality of air you need, then they'll provide you with the equipment that you need to meet that quality standard. So like I said, the ISO 8573 is a common language between you, the manufacturer, and the equipment providers. So frequent precautions, or what we normally find with pharmaceutical companies, is that they will use an oil-free compressor to completely eliminate the risk of oil vapor coming into contact with the products. They will also have a desiccant dryer that provides air at -40 degrees Celsius pressure. That is class 2. And they will also have line filters and point of use filters that ensure that any particles or colony forming units do not come into contact with the product. I hope I understood your question, Mohammed, and we have a couple of minutes for maybe 1 or 2 more questions before we wrap up, because it is time. So, as a compressed air services company, we do have some other webinars coming up that might be of interest to you. That is compressed air piping in April and compressed air monitoring in May. And we look forward to hearing from you about any questions that you might have on compressed air quality testing, and any case studies that you would like us to share with you. So with that, I'd like to wrap up. As I said before, we'll share the recording with all the participants. After this, and we do have a follow-up question from Mohammed. How long do I have to observe compressed air after qualification to ensure purity? So again, we talked about the frequency of testing, which you can determine, which can be either random, where you pick a certain number of critical control points, or you could make it very regular, quarterly. So the key thing with doing the compressed air test is the first quality test will tell you where you are. You can also have testing where you do testing before and after filter changes, or before and after service of your compressor and other filter equipment to determine, am I changing the filters too frequently, or am I changing them after too long? So for example, with filters, we recommend every major service or every 6 months, you change out the filters that remove compressed air particles, but maybe where your compressors are located, there is a lot of dust or other contaminants, and you need to change the filter more regularly. So testing will allow you to determine, are you changing the filters frequently enough or too much, or should you just stick to the normal preventive maintenance plan? Thank you, Mohammed, for your question. Do we have any other questions as we look at wrapping up? Okay, so I'd like to thank you all. It's now 4:10. I'd like to thank you all for joining us for this webinar, and I hope that it's been informative to you about compressed air quality and how you can use the hazard critical control point procedures to reduce the risks associated with compressed air coming into direct contact with your products. And with that, I will thank you and you're free to leave at your pleasure. We look forward to hosting you in future for other webinars. In addition, if you do have any testing needs or have any further questions, please feel free to reach out to us, and we'll be very happy to visit you and even help you with your risk assessments for compressed air. Thank you.